So first thing, it says if the area from -6 to 5 is 7, find the area from -6 to -2. And so what I did is I said the area from -6 to 5 is the same as -6 to -2 plus -2 to 5. Does that make sense? Okay. And so then I left this because that's what we were solving for, is the area from -6 to -2. And so then I did the work to find the area from -2 to -5. So when I looked at the picture, I said that that was 1/2 times base times height. This was 1/2 times base times height, but on the opposite side, so those two areas are going to cancel each other out. We should not have laptops open at this point, so those should be closed. Thank you. This is 1/2 base times height, but your base is 1/2. So I have positive 1/2, negative 1/2, negative 1/4, positive 1/4. So all of those areas are canceling out. Here I had a trapezoid, so 1/2, the height of the trapezoid I said was 1, but that's kind of like the width. And then base 1 plus base 2. And then for this shape over here, what I did is I said the square was a 3 by 3 square, so that's 9. And then I subtracted off the quarter circle. So I subtracted off 1/4 pi r squared. So 1/4 pi 3 squared. So I ended up getting that that area was 9 minus 9/4 pi. Yes?
Okay. Is your little downwards triangle -3/4?
-3/4 down here, yeah. So that's where I was saying 1/2 plus -1/2 plus -1/4 plus positive 1/4. 2 was my trapezoid. And then 9 minus 9 pi fourths was the last little bit underneath that quarter circle. So I went ahead and I combined those. That gave me 11 minus 9 pi fourths. So I had 7 equals the area from -6 to -2 plus 11 minus 9 pi fourths. So I minus the 11 over to get -4. And then I added the 9 pi fourths over the other side. And so that's what I came up with for my area. Any questions on that? Next it said to evaluate the integral from 3 to 5 of 2 times f prime of x plus 4. So what I did is I rewrote that problem using what I know about the properties. And so I split it up. I took the 2, I moved it out front as a coefficient. I called that f prime. And then I just left the 4, so I broke it up as like 2 separate integrals. And so over here, I was able to say, okay, that would just be f of x, right? The antiderivative of f prime is just f of x. So I have f of 5 minus f of 3. Over here, the antiderivative of 4 is 4x. So I have 4 times x, that's 4 times 5 minus 4 times 3. So over here, f of 5, if you look at the picture, is 0. F of 3 you get from the information in the problem. They said that there was a known point in the problem, and that known point was an x-coordinate of 3 and a y-coordinate of 3 minus root 5. And so that's where that came into play in the problem, was right here. So I had 2 times 0 minus 3 minus root 5. And then over here, I had 4 times 5 minus 4 times 3. So I had -6 plus 2 root 5, and then plus 20 minus 12, which is 8. So 2 plus 2 root 5. You should be okay writing just this. No simplifying, writing just that should still be fine. Okay. For part C, it asks you to take this and find the absolute maximum value. So you can't just jump into like, oh, I need to read that graph like a derivative graph. You have to do the second fundamental theorem of calculus to show that that's why you know that that's a derivative graph. So what I did first is I just wrote out g of x equals this part right here, that integral. So I said g prime, and then I showed my work for the second fundamental theorem because that's how my brain works. You did not have to show work for that. You could have just said g prime equals f of x. That would be fine. So once I said that, I looked at the different areas underneath the curve because this was saying the absolute maximum. And if you guys remember the extreme value theorem, the absolute maximum is going to use not only the place where it switches from plus to minus, but it's also going to use the end points. So I was using the end point of 0 and the end point of 5. on the interval. And then I was using -1 because that was where I saw a maximum happening. Or I wasn't using, I'll explain in a second why I use 0. So the maximum is right here. That doesn't make sense. Hold on, let me think. So this, it started off decreasing for a while, and then, no. Oh, it started off increasing, and then it decreased for a while. Why did those numbers make sense? I did this last week. I was working ahead, which may have been bad. I used -1 because that was a max. Went up and then came down. Looks like I should have used -2 and 5, but I used 0 and 5, and then I didn't pay attention when I did it. Yeah. So this should have been -2, not 0. Let me, well, yeah. Once I figure out why I use 0.
If you evaluate more points than that.
If you evaluate more, you're fine. Because think about how these are usually graded. They usually say, like, includes endpoints. My turn. When they grade these, they would often say includes endpoints, and then they'll say considers other points. So when you're looking here, you can see that this looks like it's a relative maximum. That looks like a relative minimum, so we don't have to consider that one. So you might have used that one, but the one they're probably going to give you points for considering is this one. Does that make sense? Because it's a relative maximum, but we don't know if it's absolute or not. It's totally fine that you considered extra points. Yeah, that's not a big deal. I think what I did is I knew the area was going to be 0 because it was -2 to itself, and I just wrote 0 on accident, I think. So left endpoint, right endpoint, and then where we saw the relative maximum. So what I did to find the y-coordinates of each of those is I needed to find what g of -2 was, what g of -1 was, and what g of 5 was. And if you look back at the problem, to find g of -2, you're going to have to plug in -2 for x, and you're going to have the area under the curve from -2 to -2. Does that make sense? So the area under the curve from -2 to -2 is 0. That's one of the properties we learned. To find g of -1, you have to look at the area under the curve from -2 to -1. Does that make sense? And then g of 5 is going to be the area under the curve from -2 to 5. So that's how you find your y-coordinates. And then what I did is I just looked at the size of the y-coordinates. I knew that the absolute maximum value was the y-coordinate. It's not the location. The location is 5, but the actual value itself is going to be 11 minus 9 pi fourths. The work that I did right here was me just making sure that 11 minus 9 pi fourths would be bigger than 1/2. So I didn't do perfect math there. You can see that I said that 9 times pi was approximately 9 times 3. It's a little more than 27, maybe 28-ish. And so I said that would be about 11 minus 7, but that's not accurate. That's just an approximation to make sure it's bigger than 1/2. Okay. The last one, did anyone look at this and automatically assume it was L'Hopital's? Because it kind of feels like it should be. Anyone do that? I did that too, and it was not L'Hopital's. It was just a direct substitution problem.
Not nice for it.
I mean, it has an arctan in there, which is not my favorite thing, but it wasn't as terrible. Yeah, it's one. We'd have to look and see what they say on the grading sheet, if they would have taken this, or if they had to have that. So 10 to the 1 minus 3 times, my guess is you probably have to go a little bit further because you have to say this is 3 times 2. You have to know what f prime of 1 is. Yeah.
Is it okay to rewrite it as tan to -1?
Tan inverse, yes. That should be fine. Yeah, that should be fine. So it's 10 minus 6 over 1 minus pi fourths, because tan inverse of 1 is pi fourths. So at least they gave you a tan inverse of 1 instead of a tan inverse of like root 3 over 3.
What is that? The tan inverse of 1 is the only one I know.
Tan inverse of root 3 over 3 is pi 6. I was looking up because I was picturing the unit circle and doing some math in my head. Yeah. All right. So let's go ahead and look at the student sample. Why do you need to graph it? You have to, it's calculator active, you have to see where they cross. So you do have to graph this one. That's very common with the calculator active problems. You do not get to guesstimate what that point is. It's often a decimal that is not a very nice one. I think this one happens to be nice.
Yeah, I think it's because the C is 4, and it's just where x 4 minus 2.3 x cubed is 0. And so you can just equate that. Also, I was going to say,
yeah, I'm ignoring everyone, actually. Yeah.
Yeah, that one's easy to solve.
Gosh, it's here. Oh. There we go. Okay, now what do I do? Number 5. Okay, it is 2. I have 2.3. Did I type that right?
Yeah.
Oh, I missed this right. Well, if you phrase that like that to a professor and they're going to hate you, they're going to be like, what's that kid's name? And then they're going to hate you. I told you, professor, you could do that by hand. No. I know, but you did. All right. Yeah, probably. Wolf. It's Wolf.
Interrupting Rice while she's teaching to say something unnecessary about that. Well, actually, specifically, just to go over that, I'd like to.
All right, do you guys notice this? What is that? It's scientific notation for 0.0000467. So your calculator is struggling to say 0. Desi, I'm going to throw that against the wall. Or you can put it in prison. Yeah, let's put it in prison. And Dugan, let's turn around and face the front. You guys just having a conversation back there. Yeah, let's turn the chair all the way around. Marvelous. Okay, so the intersections are from 0 to 2.3. We're trying to find the volume generated when you spin it around the line y equals -2. Is that a disk method or a washer method? Washer. So I need to know what my R is, what my big R is, and what my little r is. So big R is going to be 4 minus -2. And then my little r, I'm going to call f of x minus -2 because that is safer for me to write on my paper because I won't accidentally have a typo. Yes. Big R is the one that's furthest from the axis of rotation, and then little r is the one that's closer. So I did top minus bottom, 4 minus -2, and then I did f of x minus -2. So what I have is I've got the pi in the front, 0 to 2.3. There's my big R squared minus there's my little r squared, and if you typed it with no typos, you get 98.868. Okay. All right, next they say we're finding the volume by perpendicular cross sections. It says perpendicular to the x-axis. Why is that important? Everything is in terms of x. What was your question?
It was from that thing earlier. Why did it give you mathematics 0? That it should be a perfect 0. Why was the calculator struggling?
It was struggling to say 0.
Like, was there a reason why?
I think your calculator just has, it's like good to a little bit of accuracy, but when you spread it out, then it...
Yeah, it just sometimes
All right, part B says x-axis, perpendicular to x-axis, isosceles right triangle with a leg in R. Do you guys remember what they're telling you when they do that, when they phrase it like that? Yeah, they're telling you that the base of the triangle and the height of the triangle are the same thing. So the reason they said a leg is in R is because they're telling you the hypotenuse is not what's in R. So it's not the longest side, it's the two sides that are the same. So the formula for area of a triangle is, Yeah, 1/2 base times height, or in this case, s squared. So we need to figure out what our slice is, and our slice is going to be top minus bottom. So that's 4 minus f of x. And so we have 1/2 times 4 minus f of x squared. The danger in writing it the way I wrote it is if I wrote a plus instead of a minus, or if I had my squared or my parentheses funky, then I would not have gotten any points for that. So just be careful if you're going to write out the actual function. 3.574. Do we get that? Yes? Okay. The vertical line x equals k divides R into 2 regions with equal areas. Write but do not solve an equation involving an integral expression whose solution gives the value of k. These are not my favorite because they're kind of nitpicky on these. So I wrote 0 to k of top minus bottom equals 1/2 times the integral of 0 to 2.3. So that's me showing that 0 to k would be exactly half of the area. Does that make sense? You cannot say 0 to k plus k to 2.3, because when you do that, you're not saying they're each half. You're saying that one of them plus the other one equals the whole, and that could be 1/4 of the area plus 3/4 of the area equals the whole. Does that make sense? So you have to have it in there that this is half. Did everyone catch that? So if I wrote the integral from 0 to k plus the integral from k to 2.3, I do not get points, because that is not necessarily half of the area. That's just one part of the area plus the other part of the area equals the whole area, which is 2 different things. Yes?
So neither of the functions would be squared?
No, because it's just talking area. Yep. So top minus bottom. Okay. Mm-hmm. 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 Because you can divide something into areas, but they're not necessarily equal. So if you do 0 to k and k to 2.3, you're dividing it into 2, but not necessarily 2 equal areas. Yeah, no need to find the answer. There's a reason they said just do it and don't solve. Well, there you go. All right, so let's go ahead and get the student samples.